Welcome to Study Loop.
In this question, we have a pot of steel being heated in a hot stove, and we are boiling water here. So the water is at 100 degrees Celsius, and a portion of the water is being evaporated every 3 minutes. So 3 minutes is 180 seconds. We already converted here, and they want to know the temperature of the lower surface of the pot, which is in contact with the stove, so the hot temperature here. We know that the temperature at the top is 100 degrees Celsius, and we know that it is boiling water at a constant rate. So we can calculate the heat that is being generated here. So let's write here. So we can calculate Q of the water that is being evaporated. So we have to have heat transfer to the top enough to boil the exact amount of water, that is 0.390 kilograms. So mLV, LV is the latent heat coefficient of the water. So this is 0.390 kilograms times 2256 times 10 to the 3. So we have here Q is equal to 8.798 watts per second. This could be written as joules as well. And because we know the relation between heat transfer and the heat, so the heat transfer is how much heat we have at a given time being transferred. And we know that this T here is the time. So let me write here as time. And we just need to substitute them to know how much heat flow we have. This will be 4.888 watts. Now, with this information, we can find the temperature at the bottom because we know now. So let's keep this information here, and we don't need this information anymore. Now we just need to write the equation for the heat flow in terms of the difference between the temperature. So this will be the heat capacity and the area delta T over delta L. And we know everything here. We know delta T. We don't know delta T actually. We just know the final temperature. We don't know the initial one, and we just need to solve this equation in terms of delta T. So this, we can invert this. This would be T hot minus T cold is equal to HL divided by KA. We have everything here in the right side with these values here. We can just plug in. This gives us 5.52 degrees Celsius. And because TC is 100 degrees, we find that so let's move this a little bit up. And we find that T hot is 100 plus this value here, that is 105 0.5 degrees Celsius. This is the difference, the temperature in the bottom of the stove.